In this third demo of the series, we will show how to enforce a strict security policy on the flow of information in a Spark program, thus ensuring that confidential information is not leaked on a public channel. First, we need to define confidentiality levels with higher values corresponding to more secret data. This should not be used to compute the value of less secret data. Here, level confidential corresponds to data which should not be leaked, and public corresponds to non-confidential data. Then, each piece of state in database can be given a confidentiality level. Identity data is confidential here to protect individual rights, while the balance data is publicly available for inspections from banking authorities. We could leave balance data as it is, as the public level is the default. Just running the examiner in the special security mode shows that there are no current leaks. Now, let's consider data movements involving confidential and public data. Let's say there is a backup procedure whose role it is to back up the database through a connection to a remote data center. The channel package defines a piece of state regular channel, which is marked as out, meaning that the program is allowed to repeatedly write it in without overwriting it like a normal variable. A procedure send data is responsible for sending a chunk of memory through the network, where a chunk is given by its memory address and size in bytes. Going back to the backup procedure, it should derive the new value of the channel state based on the input value of identity data and balance data. Let's run the examiner. It detects a problem. Indeed, we're saying here that the secure identity data is going to be sent on a regular channel, which violates the security policy. Instead, there should be a secure way to send over secure data. So let's add a procedure, send secure data, operating on a secure channel with the appropriate confidentiality level. If we declare that identity data is sent on this channel, then the examiner checks that this respects our security policy. Note that the examiner also validates that we can send both confidential and public data on the secure channel. Let's now look at the implementation of backup. The annotations are the expected ones. We are calling send secure data and send data with the address and size of the arrays holding the account and account balance data. A subtlety here is that Spark forbids the use of attribute tick address, which must be isolated in an ADA piece of code hidden from the Spark toolset, as indicated by this hide annotation. Running the examiner shows that the implementation respects the security policy. Let's try sending identity data through the regular channel. This is detected by the examiner. Let's summarize what we've seen. The Spark language allows you to define secure flows of information through a program. The examiner tool checks that information at higher levels of security is never leaked to lower levels. Note that a dual policy for safety checks that unsafe data, for example entertainment data in a plane, cannot influence safer data, for example, command and control system of the plane.